The Voyager project is one of NASA's longest-running space missions, having been in operation for more than 40 years. The two spacecraft have made flybys of multiple planets while rushing across outer space. Sending back magnificent images and other data has broadened our understanding of the cosmos. What is the Voyager 2 seeing? And what can we learn from them? The Voyager has made further astonishing discoveries of the cosmos billions of kilometers distant from us. Join us as we look at the Voyager's final photographs sent from orbit. Welcome to Cosmos Observer, where nothing goes unobserved in the universe. NASA was at the forefront of space exploration in the 1970s, and it was an exciting period. During this time, the CIA devised the objective of investigating the far-flung planet. The original aim of NASA was to take a grand tour of the Earth. During the late 1970s, someone used 4 very complicated spacecraft to study the 5 outer planets. But NASA abandoned the plan in January 1972 owing to predicted costs of $1 billion, and instead, the Voyagers advocated launching only 2 spacecraft to Jupiter and Saturn in 1977. The 2 spacecraft would examine the 2 gas giants in more detail than the Pioneer 10 and Pioneer 11 spacecraft. The intention was that if the first Voyager was successful, the second would use gravity assist procedures to reroute to Uranus and eventually Neptune. NASA launched Voyager 2 on August 20, 1977, intending to study the outer planets and interstellar space beyond the heliosphere of the Sun. It was launched 16 days before its twin Voyager 1 on a course that took longer to reach the gas giants Jupiter and Saturn, but allowed for more contact with the ice giants Uranus and Neptune. It was part of the Voyager program. It's still the only spacecraft to have visited both gas giants and both ice giant planets at the same time. Voyager 2 was the 4th of 5 spacecraft to reach the solar escape velocity, allowing it to depart the solar system. Each of the Voyager spacecraft was equipped with a slow-scan color television camera that was used to photograph the planets and their moons. They also launched a slew of experiments to collect data on the planet's magnetic, atmospheric, lunar, and other systems. The Voyager spacecraft was initially known as Mariner 11 and Mariner 12 until March 1977, when NASA Administrator James C. Fletcher announced that they would be renamed Voyager. This was because the 2 spacecraft's design was based on the older Mariners. How can you sustain the power of a spaceship for almost 4 decades? What will be the source of power? Each of the Voyagers is equipped with 3 radioisotope thermoelectric generators, or RTGs, positioned at the end of a boom, as NASA calls them. One of the most basic types of nuclear power is this: layers of thermocouples around a brick of radioactive material, which exploits the temperature difference between the hot radioactive brick and the cool area to limit electrical power. Plutonium-238 is used in the RTG units aboard the Voyagers 1 and 2. This isotope of plutonium decays exclusively by emitting alpha particles absorbed by the RTG and doesn't irradiate the spacecraft's other electronics. The quantity of electricity produced by plutonium decreases as time passes, and the brick gradually cools. As the brick cools, the thermoelectric generator's efficiency decreases. Because plutonium-238 has a half-life of 87.7 years, the spacecraft's power supply would reduce by 0.787% per year. However, the actual electrical power available has decreased somewhat faster than that due to the thermocouple's efficiency decreasing and the progressive degradation of various electrical components in the spacecraft. In fact, at the end of 2000, after 23 years in flight, the spacecraft's power supplies were only producing about 67% of what they were a year before. On April 24, 1979, the first photos of Jupiter from Voyager 2 arrived, gifting us with time-lapse videos of atmospheric circulation. Voyager 2 made close passes to the Jovian moons on its route into the system, unlike Voyager 1 with scientists particularly keen on learning more about Europa and Io. The Jovian system as a whole, comprising its moons Callisto, Ganymede, Europa, Io, and Amalthea, was captured in breathtaking photographs as a result of this near approach. Voyager had already studied these moons, but Voyager 2 was able to travel closer, coming within 127,830 miles or 205,720 kilometers of Europa. The smallest distance between Jupiter and Voyager 2 was roughly 400,785 kilometers or 645,000 kilometers. It sent 17,000 fresh photos as well as new data on the planet's clouds, 4 newly found moons and ring system. Remember, the Pioneer spacecraft that flew by Jupiter and found minor atmospheric changes from one visit to the next. Still, Voyager 2 found several major changes including a drift in the huge red spot and changes in its form and color. We were able to image at least 80% of the surfaces of Ganymede and Callisto at a resolution of around 3 miles or 5 kilometers 2 hours after its closest approach to Jupiter, thanks to the combined cameras of the two Voyagers. The first flyby gave NASA a close look at Saturn, providing them with an enormous amount of data, such as detailed structure in Saturn's rings, but more importantly, it gave NASA ideas for the second flyby, which would take place just months later. Those ideas gave Voyager 2's flyby a lot more focus and purpose, and the images it sent back were much closer looks at those rings, especially the narrow outermost F-ring, which NASA wanted to look at more closely. It came so near to Saturn that it could see the kinks and braiding in the rings in great detail. Many people assumed that the rings of Saturn would be boring, simple, and predictable before Voyager 2 arrived. Instead, the rings were discovered to be complex, dynamic, and complicated structures. The Uranus findings discovered by the Voyager were even more amazing. Voyager sailed past Uranus, the seventh planet from the Sun, in early 1986, just a few years after its flyby of Saturn. It took a plethora of incredible photos and returned them to Earth. Voyager's observations revealed 2 additional rings encircling the planet, as well as 11 unknown moons. It's also revealed how frigid Uranus truly is. As Voyager continues to travel through space, it's getting further and further away from Earth, which is a good thing because one of Voyager's primary objectives was to peer into our solar system from the outside. It wasn't known when the spacecraft was launched if interstellar travel like this was conceivable or if Voyager would survive such a long journey across the universe, but it did, and it's gone the distance. Both Voyagers 1 and 2 have officially crossed into interstellar space, which means they're now transmitting photos and data from far beyond our solar system. Both spacecraft flew through the heliosphere. The heliosphere is a bubble or boundary created by the Sun surrounding itself and its nearest planets. The heliosphere is created when the solar wind from the Sun interacts with wind from deep within interstellar space to form a bubble that shields the Earth and the rest of the solar system from harmful cosmic rays. Now that the Voyagers have passed that threshold, any photographs they capture will provide us with a new viewpoint in our solar system that we didn't have previously. Even though it's so far away and has been in space for such a long time, Voyager continues to surprise scientists with its fresh discoveries. New research has announced the discovery of a new signal by Voyager, specifically by the plasma wave system on board the spacecraft. What appeared to be a faint hum was a deluge of data that experts sifted through. The team was able to derive a new measurement of the density of the mixture of molecules, atoms, and ionized plasma that fills the space between our stars based on these findings. It was the first continuous measurement of plasma density, and it took place years after the craft was launched into orbit for the first time. Voyager is still doing amazing work after all this time. When it's all said and done, there's a lot to be proud of for the Voyager and its crew. Voyager 1 took almost 19,000 photographs of Jupiter at the start of its trip in 1979, while Voyager 2 took 33,000 images just a few months later. These were the greatest images of Jupiter and its 5 main satellites that we had ever seen, and they set the tone for what Voyager might do. But the image that stands out the most isn't of a faraway planet or object, but ourselves. Scientists from all around the world have examined the pale blue dot picture, which provides us with an excellent notion of how little and unimportant Earth is in the larger scheme of things. Our planet appears to be a tiny blue speck in the middle of emptiness in this image, which was taken more than 4 billion miles away. In actuality, the size of Earth was barely 0.12 pixels. The pale blue dot shot certainly put things in perspective and gives a sense of the vastness of the cosmos, but it's only one of the many jaw-dropping images the spacecraft has delivered us since flying out from Earth in the 1970s. Voyagers 1 and 2 were entrusted with capturing photographs and answering some key questions, and they have succeeded admirably. As a result of their efforts, we now know a great deal more about the stars and planets that make up our solar system. The Voyager is still working hard after 40 years.